And now we have our question here on the board. Okay? The question says, below is the score of a sample of 45 randomly selected students in a statistic examination. These are the scores, so that's the distribution. Now we are asked to use number of class interval of 9 and construct a frequency table for the distribution to include all the features of a group frequency data. And you would recall that we have treated all the features of a group frequency distribution. Is that not so? Starting from class interval down to what? Our percentage frequency. So of course, it's believed that you have an idea of all of those now. We're going to construct a table that will contain all of those features. But how do we start? You would recall that I mentioned that the first and most important thing is to set up your what? Class interval, which of course is dependent on class width or class size. So first we're going to get our class size or class width. And how do we get it? From the data given to us, the number of class interval according to the question is 9. We don't know our class width, so I'll say that W is equal to question mark. We'll quickly go and get our class width, because you know that class width is what will help you set up the class interval. So it's going to be W, our class width, equal to range R divided by number of classes. Now to do that, how do you get your range? Range is highest observed value minus lowest observed value. The highest value here is what? 94. The lowest value is 50. So we're going to do 94 minus 50. That gives us our range. Then divide by number of classes, 9. Of course, if you punch this in your calculator, please, you need your calculator as your best friend in this course. Take note, because you are going to punch. You will punch and punch calculators. Now, let's work in this and see. 94 minus 50 is giving me 44, and then divided by 9, you're going to have 4.888 continuously. You would recall in our previous class that we stated once you evaluate this and you are getting a decimal number, what do? Approximate by rounding up to the next higher number. So we're going to round up this to what? 5. Therefore, the class width for this problem is 5. And once I've gotten this, I will smile. I can use this to set up my class interval now, which every other column will be derived from in such a way. Now let us quickly set up the first two classes and see. If the class width is 50, how do I set, is 5 rather, how do I set up the class interval? The lowest number is 50, so the first class will start from 50 to, where will be the upper class limits? How do you do it? Now let us start. It's going to be the 50 there, add this class width 5, and then subtract 1 from it. 50 plus this 5 is 55. If you subtract 1, you are going to get 54. The reason why you are adding the 5 and subtracting 1 is because in class interval, this number and this, that is the lower class limit and upper class limit, are inclusive in that 5. Is that okay? So if you add this 5, you need to remove 1 to balance it out for class interval. The next one will be from 55. Add this 5, you will get what? 60. And then subtract 1 from it, you get 59. You get this, right? So we're going to take a break. When we come back, we'll now work on the full table. Right now we have our table on the board now. The group frequency distribution table for our 45 randomly selected student scores in statistics examination. Now, how did we come about this table? Recall that before the break, we already calculated the class width we are going to use, because they gave us what? Number of classes. We calculated the class width to be 5, and before the break, I set up these first two classes. So I believe from that knowledge, you know how the remaining came about. Is that okay? So you walk through that. Now, frequency, how do you get it? It's very simple. You go to the distribution, to the scores given to you. Like these 3, how did we get it? You go there and start tracing row by row. How many scores fall in this range from 50 to 54? So you check and count. If you do that, you notice that 3 scores fall in this range. So that frequency will now be 3, because frequency is the number of times a particular value appeared in a distribution. Then the scores that fall in between 55 to 59. Remember, 55 and 59 inclusive. If you do your counting again from that raw data given to you, there will be 5 of them. So do same for all of them. Please, once you are done getting the frequency completely, make sure you sum it up. It's very important for further calculations. We're going to meet that as we move on in the course. Class boundary, I'm very, very interested in that. How do we get the class boundary? Remember we had the formula already that to get the lower class boundary is going to be the lower class limit plus the upper class limit of the class above it divided by 2. Now, we don't know the class above this thing, but we can use the knowledge that the class width here is 5. If the class width here is 5, it means that if we were to have a class above this 50 to 54, it's going to be 45 to 49. Check that, you see. Therefore, to get the lower class boundary, you do the lower class limit here plus the upper class limit of the class above it, which is 49. If you add 50 plus 49, you get 99. Then divide it by 2, you get 49.5. That's how you get the lower class boundary. Then for the upper class boundary, again, in the formula we say, to get the upper class boundary, it is the upper class limit of the class you are treating plus the lower class limit of the class after it. So if you add 54 to 55, what will you get? You get 109. Then divide it by 2. You now get the upper class boundary of the first class. The same thing you do for this. To get 54.5 here for this class, is going to be the lower class limit here plus the upper class limit. That is 55 plus 54 divided by 2, you get this. And then to get the upper class boundary of this class, it's going to be the upper class boundary of that class plus the lower class limit, rather, that is upper class limit of this class plus the lower class limit of this interval, which is 59 plus 60, divided by 2, you get 59.5. We can do for the rest. Now here we have our class mark. Class mark is simple. Either you do lower class boundary plus upper class boundary divided by 2, you get this for each of the class, or you use the class limits. Lower class limit plus upper class limit divided by 2, you get that here. Now if you get the first one, to get the rest is quite simple. Just start adding up the class size. Like here the class size is 5, is that not so? So if you have 52, add 5 to it, you get 57, add 5 to it, you get 62 in that order. Now you notice I use black marker for values that we obtain from the score. Frequency is just independent on it when you go by counting. Now from here I used blue marker. This is lower cumulative frequency. That is less cumulative frequency, less than. Then this is more than cumulative frequency. This is relative frequency, this is percentage frequency. You have the formula already on how to get that. For the lower or the less than cumulative frequency rather, how do you do that? Come to this frequency. So all these blue marker writing are values you obtain from frequency. So for here you start adding 3 plus 0 will give you 3, plus 5 you get 8, plus 8 you get 16, 16 plus 10 you get 26, 26 plus 7 you get 33, 32 plus 6 you get 39. You do that down to the last will be 45. And then for more than cumulative frequency, you add from down up. 1 plus 0 will give you 1 because there is no frequency below this. Then 1 plus 2 will give you 3. 3 plus 3 will give you 6. 6 plus 6 you get 12. 12 plus 7 you get 19. 19 plus 10 you get 29. Do it down to the last you get 45. Relative frequency, you've been told that it's going to be each of this frequency divided by the total. So 3 divided by 45, you get this 0.067. You can do that with a calculator. Then 5 divided by 45, you get for the second, which is 0.111. Do that for the rest of them. Now finally, for the percentage frequency, simply multiply the relative frequency by 100, you'll get this, each of them. If you sum, I've told you already, this will be 1, this will be 100. Now this, I just put it is not compulsory, just to identify the position of the class, first class, second class, like that, down to the 9th class. So that's how we got the table, alright? In this video, we want to say how we can determine the median of grouped frequency distribution. You would recall previously that we treated how to get the median for ungrouped distribution. Now, for grouped data, it's important to know that the median is not as straightforward as it could be if you're talking about median of ungrouped distribution. To obtain the median for a grouped frequency distribution, one can go about it in 2 different ways and then arrive at almost the same result. Alright? One of the method is by formula, calculation method. The other method is graphically, where we obtain the median from the less than cumulative frequency curve, known as the Ogilvy curve. In this video, we are going to focus more on how to obtain median using the formula. And on the board here, we have the formula that is used in calculating median. Just similar to what we saw for mode. How to estimate mode by calculation. Now let us look at the formula here on the board. To get the median is equal to x subscript me, which is the lower class boundary of the median class, plus open bracket summation of all frequencies divided by what? 2, minus cumulative frequency of the pre-median class, that is the class before the median class, divided by the frequency of the median class. Close your bracket and multiply by the class width, C. Our C dot F subscript ME minus 1, because I stated already, it means the cumulative frequency of the class before the median class, known as the pre-median class. For us to use this equation 11 to calculate the median, the first and most important thing we have to do is to determine the class known as the median class from our frequency table. If we are able to determine the median class, then we can be able to obtain the values of all these frequencies of the median class, cumulative frequency of the pre-median class, the lower class boundary of the median class. So take note of that. You must have to determine the class known as the median class from your group frequency table. Now, how do you obtain this median class? So it's important you go through this. Is that okay? The first thing you do in order to determine your median class is to obtain summation f all over 2 value. That is the total frequency divided by 2. Now, once you obtain this total frequency divided by 2, the next thing you need to do is to go to the cumulative frequency column of your table and see if you can obtain this value of summation f over 2. If that value is there in the cumulative frequency column, then that row will become your median what? Class. But suppose on going to your cumulative frequency column, you check for the value of summation f over 2, and that value is not exactly there. Then take the next cumulative frequency value that is just greater than the value of summation f over 2. That would be your median class. Then you can pick out the necessary data, input into this equation 11, and solve for the median. In the next video, we're going to take questions and see how we apply this formula. In this video, we are going to attempt to obtain the median of the scores of some students that sat for statistics examination. We are going to use the formula method to obtain the median. Look at the question here on the board. Using the scores of the sample of 45 randomly selected students in a statistic examination, reference was made to table 2A. Calculate the median score of the students. Okay, so how do we solve this problem? You would recall that in the previous videos, we've already established this table 2A from a given problem. It's a group frequency distribution problem actually. And so we are asked to find the median score of these students. So what do we do? First of all, we have to bring out the required table, the column we need from table 2A. Remember, you're calculating the median. So you need the class boundary column, you need a frequency column, you need a cumulative frequency column, alright? Of course, the scores of the student, important as well too. These are the things you need because of the parameters that are seen in the median formula. So how do we go about that? First of all, let's recall the formula we need to obtain the median score. So recall, we obtained already that median is equal to that is lower class boundary of the median class, right? So we're going to add it to open brackets summation of the frequencies divided by what? 2 minus the cumulative frequency of the pre-median class all divided by the frequency of the median class. We're going to multiply this term by the class width of the median class, supposedly. Good. How do we obtain these values for these parameters we have here in the formula? We have to go and determine the median class from this table first. So how do we get the median class? To obtain the median class, because we know that we need summation f over 2. And summation f, the frequencies added together is 45, divided by 2 is 22.5. Now, get your pen, get your book, and write what we're going to do from here now to get our what? Median class. We've obtained 22.5 from summation f over 2. Look at this part of the formula, very, very important. Not just for calculating median, but for calculating fractiles, that is measures of positions, the quartiles, the deciles, the percentiles. Very, very important. We're going to encounter it again when we talk about those measures of position. Alright, with this 22.5 as the value of summation f over 2, now go to the cumulative frequency column. Are you there with me? So this is the cumulative frequency column. I'm going to check if I will get 22.5 there. So I'm going to ask you, did you say the 22.5 in the cumulative frequency column there? Did you? Alright, good. No, there is no 22.5. Because there is no 22.5, what do? You're going to pick the next cumulative frequency value that is just greater than 22.5. And of course, if you look at this, 22.5 will be between 16 and 26. Is that not so? Now, if 22.5 is between 16 and 26, means that the next greater cumulative frequency of this problem is going to be what? 26. Therefore, we're going to pick this as the median class. So, let me roll out something like this. This is our median class. Hence, all calculations will be based on that class. Alright? So, we're going to obtain the values of all these parameters. It implies that SME, that is the lower class boundary of the median class, will be located here at 64.5. 64.5. Then we have the pre-median cumulative frequency. Right, now the cumulative frequency of the pre-median class is what? 16. That is the class just above the median class. 16. And of course, we need the frequency of the median class. Frequency of the median class, look at it, that's 10. Then we need the class width. How do we get the class width quickly? Upper class boundary minus lower class boundary. So we're going to do that here, 69.5. 69.5, I'm using that of the median class. Then minus 64.5. And that's going to give me 5. You can use any other class to obtain the class width, but preferably, let's just base our calculation on the median class. Having obtained these terms, I can now calculate the median. So my median score will now be equal to lower class boundary of the median class, 64.5, then plus summation of the frequency divided by 2. We already got it to be 45 over 2, which gave us 22.5. So I can just put the value there, 22.5, then minus the cumulative frequency of the pre-median class, which is 16, all divided by frequency of the median class, which is what? 10. We're going to multiply by the class width, 5. So the median, our median score will now be 64.5. We're going to add it to, let's be done with everything we have in bracket here and multiply by 5. Are we ready? So let's switch out for our calculator and press 22.5 minus 16. It's giving me 6.5. So I'm going to divide that 6.5 by 10, 0.65. So this whole bracket is 0.65. Let's now multiply it by what? 5. That is 3.25 here. I'm going to add this to 3.25. In conclusion, the median score for this student in this statistical examination is equal to, if we add this 3.25 plus 64.5. So from here it's giving me 67.75%. So this is the median score of the student in this statistic exam.